Hello friends. So now the time of insertion of node at a specific position in the linked list. Okay, so till now we have seen how we can insert a new node at the beginning of a linked list and how we can insert a new node at the end of the linked list. Now let's say we are not told about whether it is beginning or end. We are just given a linked list like this. Let's say this linked list has already four nodes or maybe no nodes or whatever. Like this is just an example. And we have one head pointer pointing to the very first node as usual. And these are our node with the data in it. Okay. So these are the dummy datas that I have been feeding. Okay, and this is our last node with the null pointer in the next part. Okay, and this is our head pointing to the first node. Now, let's say we don't have to insert here or here. Let's say we have to insert at the second position. Okay, we will be provided this position, of course. So at this specific position, let's say we have to insert a new node. So, definitely you might have understood like we will definitely need to update some pointers and fix this node here so that this points to this new node and the new node next points to this node, right? So, it is very simple. But before getting down into this, I would like to say that we had already seen about a function called the list length, right? So this list length function gives us the length of the entire linked list. Why it is important here? Like if we have to insert the any new node in the linked list, we need to know that the position has to be somewhere in the range from in the range of this link list length, right? For example, if the list length is 4 and we are asked to insert this new node at position number 10. Let's say the position is 10. So of course we can't insert a new node at the position 10. We can insert it at fifth position. Like it should be like if this is node number 1, 2, 3 and 4, we can insert a new node at this fifth position. We can insert the new node at the first position as well. Okay, but we can't insert anything at the position 10. So that is why this list length is important. Okay, so that we can know that our position should lie somewhere between this list length plus 1 and it should be something between greater than 0 and less than equal to list length minus 1. Okay, I mean the position should be either sorry, this is not actually the case. The position should be, yeah, of course, the position should be uh, not less than 0 is not a valid case. The position should be greater than 0, of course. This is a correct condition. Or the positions should be less than or equal to list length plus 1, right? That is, if it is fifth position, it is correct. Okay, like the position is 5 and list length plus 1 is 5, it is good. If it is 6, let's suppose the position is 6 and list length plus 1 is 5. Okay, so 6 less than equal to 5 is wrong, right? So we will check all these condition, but I just want to give some view of this. So for that, this list length function is very much important. Okay, so what was this list length function? We can re-revise this. So in the list length, what we were doing, we were returning the length of the list like int list length, and this was the function, and we were passing the head. Okay, so yeah, so here we were passing node pointer head. right? And what we were doing, we were having a count equal to 0, right? And we were checking if head equal to null, then we were returning the count as 0 only because the list is empty. Otherwise, what we were doing, we were having else in the else part, we were having this one pointer for traversing, that is node pointer q. And then what we were doing, we have assigned this q as the head, and we were checking while q not equal to null. Okay, so the very first thing we were doing, that count plus plus. So for first node we were counting, and then we were incrementing the q to the next of the pointer. Then for the second node we were having this count plus plus and so on. Okay, so this q always referred, and at last we were return the count. Okay, so this way we were doing the logic. But one thing to note here, that every time we were using this q pointer to point to a particular node, right? And we were incrementing its value, and we were incrementing the count value like that. Okay, so that is why this list length is important here. Now let's see how we can insert a new node at a specified position. So insert void insert at position. Here you need to specify the node pointer head, and of course we need here to provide the specific position where we have to insert the new node, right? Now we have this length, and we want to calculate the length. So here I have this function length, list length. So we can use this function like length equal to list length, and in that we are going to provide our node pointer head, right? We can simply provide as here head because that will be taken care. Okay, this head. Okay, so now this will calculate the length of the entire linked list. Now the very first thing is we need to see whether our position is correct or not, right? Whether the position at which we have to insert our new node is correct or not. So if position is less than or equal to 0, then of course it is an invalid position, right? Or position is greater than length plus 1, right? For example, length is 4, we can insert at 5, but we can't insert at 6 because at 5th we don't have any node, right? So this is important to check. And if it is the case, like if it falls in this, if any of the condition gets satisfied, then we can print a message like it is an invalid position. Okay, we can print like this, it is an invalid position, and we can exit out of this entire function. Okay, this is the force exit. But if this condition is not satisfied, if our position is correct, then we can have certain checks. Like suppose if position equal to 1, so we have to insert at the beginning. So definitely we need not to do anything, we just need to call our already created function insert at begin, right? Because the logic would be same. Or you can do this whole process here, like you can, instead of this you can write down, but I think it would be better if we create a separate function and call this function here. Okay, that is why this is a kind of uh, good design, right? We are calling this function when the position equal to 1. And if else if Let's say we have to insert the new node at the end of the linked list, like if position equal to length plus 1. So here we can call our another function that is insert at end, right? So these two positions are satisfied. Else, now our logic comes into picture, like if the position is somewhere between the starting and the end of the loop, entire linked list. Okay, so then of course we have to follow the same process. We need to create a node pointer temp, and we need to traverse up to that position using pointer q, node pointer q, and we need to allocate space for, and let's suppose int k equal to 1. K will be denoting the position, we'll see next. We have to create this node temp equal to uh, node pointer malloc size of node. Then we have this, we will fill temp next equal to null, and we will fetch the data from the user. What we have to fetch, enter the data, right? And next there is a scanf and percentage d, and we will take the data at data of temp. So now our new node is ready. Now we will have to look at where we have to insert. So again, we will look at, now we, of course, if it is a list, it is definitely not empty, right? Like if it would have been empty, it would have been captured earlier, right? So if it has been the first position, like there is no node already present, it could have been handled by this to function, like inserting at the beginning or inserting at the end. But since the position is somewhere between the beginning and end, so there is no case of the linked list being empty or one node. So there are some node already present there in the linked list, right? So now we need not to check further. We can just simply provide the head pointer address to Q. Now is our traversing pointer. It will traverse to the end of, to the position where we have to insert. Okay. So now here if you see, our Q points to the very first node. Let's say our position is 3. Okay, 1 2 3. So here we have to insert. It's not here, we have to insert here. Now we need to traverse till that, right? We can traverse via q. So while position, so while, so k is a integer that will be pointing to the position. So while k not equal to the position, till that we will are going to move the q to q of next. Note that k is initially assigned to 1. So we have already int length. Somewhere we have assigned k as 1. Okay. So yeah. So k is initially 1. So we will check while we are not getting the length, we are getting the position. So we our position is third position. We have to insert our new node at the third position. Okay, so the position will not be here. The position will be somewhere here, and this node needs to be shifted. That is how it will get the position 3 here. Okay, and this will come to 4. So initially we need to go till second position, right? Because we have to insert at the third position. So we have to go till second position. So it will be equal to like while k is equal to while k not equal to position minus 1. If position is third, then definitely we need to check till second, while k not equal to position minus 1. Okay, so till that we are doing q equal to next of q, and we are incrementing the value of k. Okay, let's check this till we reach the. So we are checking for position minus 1. So initially the q is 100, okay, and k is of course 1. Now k is not equal to position minus 1. K not equal to position minus 1. Position is what? Position is 3. 3 minus 1, 2. K not equal to 2. K is not equal to 2 is correct. So q will be incremented to q next of q, that is 200. Okay, this one. So now q is pointing to this, and k will be incremented to 2. Now 2 not equal to position minus 1, 2. Okay, so this will be false. So now we have reached here, of course, at position 2. So then we will come out of this loop, of course, right? Because 2 not equal to is wrong. So we will come out of this loop. And now what we have to do, we have to do some pointer adjustment. Okay, so we will update it as temp. In the next of temp, we are picking what? Suppose we have reached here and we have the temp here. Okay, this is our newly created node somewhere. So in the temp, in the next of the temp, like we have to insert it here somewhere so that it could be at the third position. Okay, so in the next of the temp, what we have to feed? We have to feed its address, right? So we have to feed what? The address of this node, like next of q. Okay, right? Next of temp equal to next of q, and in the q, what we and in the next of the q, what we have to do? Like here, if you see, our q is pointing to this. So in the next of the q, what we have to do? We have to pick up the temp address. Okay, so we are going to fill it with the temp address. This way we can insert a node at a particular position. The important point here to note is we are using this k to check whether we have reached the position or not. And the position is not according to the list. The position is one position before, because automatically if we place a node at the third position, then the actual position will be shifted one position ahead. So it we need to search for the second, and there we can insert. Okay, so we can't increase that. We can also write the loop as while k less than position minus 1. Okay, so this way we can check for that. So this is what how we can insert a new node at a given position. So this is very important, and it combines all the three steps we already discussed. So now we will look dive more into how can we find the middle of linked list, how we can reverse the linked list, and how we can delete, and and so forth. Okay, so see you in the next lecture. Keep watching and do post comment if you have some doubts somewhere. Thank you very much.